is ANTIC, the Atari 8-bit podcast.
I decided on a whim to approach Joe Decuir. Joe wrote me back about 5 minutes later. Hello, Tom. I am very impressed with your research and your findings. If you want to make your own tape formats on the Atari, go right ahead. You can bit bang the pokey to do whatever the hell you want.
I'm Kevin Savitz, and this is an interview episode of ANTIC, the Atari 8-bit podcast. Thomas Cherryhomes recently deciphered the Educational System Master Cartridge and decoded the talk and teach systems used by Dorsett Educational Systems. He's created a C library called eduendcode, which allows people to create new lessons using that format. Thomas and I are currently working to digitize and archive 46 sets of Dorsett courses, more than 360 cassette tapes in all. To hear some background about Dorsett Educational Systems and their educational cassettes, listen to my feature about that topic in episode 23 of ANTIC. This interview occurred on June 2nd, 2015. I was honestly astounded when I heard that you had figured out the system and reverse engineered it. So I'd like to talk about that, and I want to talk about why you care, why you're interested in this obscure bit of Atari history.
It's really, it's very simple, really. From the whole thing started for me when I was looking through, I'm interested in history and archaeology. And in the case of the Atari Educational System, from what I've been able to gather, the Educational System Master Cartridge was the first cartridge that Atari had planned for the PCS machines, all the way back when they were still called Candy and Colleen. I mean, it's given the first catalog number in the list. It was the first one on all the project management charts, everything. So, and it's the cartridge that nobody knew anything about. I never knew anybody that had the cartridge. I never knew anybody who had the tape, so that you had to have tapes to go with it. And so, I was astounded by it. And it piqued my interest a couple of years ago when I'm trying to remember, was it Alan Bushman who came across a handful of the tapes and started posting them up. And so at the only emulator at the time, and it's still true today, that could load these things was Altera. So I load them up and load them with the cartridge, and I'm looking at this thing going, wow, this is amazing. And I'm watching how this is working, and it's streaming the data. I knew for a long time that the Atari had the dual-track audio cassette mechanisms, but I'm looking going, this isn't block-oriented. The stuff is streaming. It's acting like the old-style S100 cassette tape interfaces that were basically modems that attached onto your serial ports, onto your Altairs and your MSIs and stuff. And so I started looking into all of this, and the pivotal point for me came when Roland over at the Atari Wiki started collecting the majority and the remainder of all of the Atari tapes and got them all in one place. And we fed them in, made sure they all worked. And then I went, I'd like to finally see how this thing actually works. I've got some 6502 experience, got some disassembly experience, and I took the cartridge apart and started seeing how it all fit together and how it worked. And when you look at this cartridge is absolutely amazing from an archaeological standpoint. It's an 8K cartridge, yes, it has an 8K ROM. The damn thing fits in 2K. The whole cartridge the whole interpreter fits in 2K ROM.
Wow.
Yeah. And, but what's even more telling is if you look at the code and see how it actually sets the computer up in the first place, the memory addresses it uses, and the address ranges that it uses. It never uses more than 4K of the entire Atari's memory space. This tells us a lot because if I'm not sure if you're aware, but originally the Atari machines were spec'd to have 4K and 8K respectively. That was the reason for the model designations, the 400 and the 800. Mm-hmm. And the way the computer mapped everything out was in 4K blocks. So this thing literally took and jammed as much as it could into one space and did all its work in there. Now, once I figured out how it was initializing everything, and I'm looking at this thing, it's talking to the Pokey directly, it's bit-banging the Pokey directory, listening for interrupts, taking over all the interrupts, and just listening for data as it comes across. Well, I fire up the emulator, I start looking in the buffer where it's putting all the data, and I'm starting to see ASCII come out, bits and pieces in that buffer. And so I start mapping it out on Notepad, just kind of finding the hex values that I'm seeing here and mapping it out. Now, so that I understood, I took the encoder as I understood it from the cartridge and made my own decoder in assembler. Mm-hmm. Just fired something up real quick, about 300 bytes worth of code, and slammed it out, watched it work, and sure enough, but it was all garbage. And I'm going, wait a minute. Something's up here. And I get a piece of information in the form of an internal Atari engineering document that's called All About Cassette Tapes. This thing has been sitting on Atari Mania for however many years. Nobody even knew the damn thing's there. Who the hell cares? Whatever. But they have a whole section in that document about the Dorsett tapes. And that the data is indeed stream-oriented, as I was finding out. But the data was being written inverted onto the tape. They're exclusive ORing every bit with FF. So they're basically, because their rationale was they wanted everything to look like the stop bit. If you look at the code on the cartridge, it makes the error correction routines and the interrupt routine a lot simpler. But that's what they did. So once I put in a little EORFF, all of a sudden, bam, I get ASCII. Okay, great. I'm seeing data. This is awesome. So little by little, I go back to the cartridge, and I'm playing different portions of the tape, hitting break at different points, and watching all the different ASCII values, and I start writing them down. And so I'm thinking, okay, well, this is frequency shift keyed audio coming out to this tape. I need to figure out whether or not I'm actually understanding what's coming out here. I need to write an encoder. So, have never written an FSK encoder before, and I kind of guessed my way through it. And about 4 hours later on an afternoon, I all of a sudden have brand new content being streamed by the into the cartridge and onto the screen from a little C program that I wrote. And that's the first new content that's been displayed from this particular cartridge in some 36 years.
Wow. So do you have the ability? That's amazing. Do you have the ability to, if do it like they do it, where you can go like, this is a circle and
yes.
Type A A circle, B rectangle, and yes, you're right. It's a circle.
Mm-hmm. The way that you think of the master cartridge literally as a terminal emulator, like a modem program of sorts. And all it's doing is it's interpreting all the codes that are coming off of the cartridge, off the tape. And in the case of the education system, the control codes are so simple, it's all 1 byte. 1 byte to turn the screen this color, 1 byte to turn the screen that color. 1 byte to set the correct answer to 1, 2, or 3. 1 byte to set the answer to wait for an answer. And, that's really the gist of it. The rest of it is basically standard ASCII. And it's, it's simple. So I figured it out over a period of a few days, just mapping all the codes. And once I had all that, crammed all that into the library, and cleaned it all up, made it a nice, simple standard ANSI-C library that is completely self-contained. It has no dependencies whatsoever. You can, if the only copy of this is that you have is a printout from a book somewhere, you could type this thing out and have it spit out a WAV file, basically.
Wow.
So, so that's basically it. And as I've done a couple of tests with the encoder, just test WAV files with it. And one of those was an idea that I had at like 2 a.m. You're kind of loopy, you've been up for a while, and you get this little chuckle. And I started thinking about all those strong bed emails from homestarrunner.com. And, he's always using these old crappy computers, and I'm thinking, what if strong bed had used an Atari 800? So I took one of his emails, number 45 Techno, and I completely converted it into education tape with synchronized the voiceovers to the text and color changes and everything. And that was, posted that up just as an example of what to do with all of this. The next step with it really is honestly to take it and turn it into somebody make an authoring tool with it. A good UI programmer could take this C library and make an authoring tool out of it in about a week. So, just whatever. If I do it, great. If someone else does it, great. Whatever. But, now as part of what I've been doing all this research, figuring out how all the bits and pieces work. And now it's like I've got this pile of stuff. What do I do? Well, it's a research project. I have to write a paper. Well, that paper has turned into a book, and the book is now. I'm just piling it on until it's basically finished. I've got everything outlined. I just have to keep knocking at it. 1,000, 2,000 words a day until I get it finished.
Do you think this is something you're actually gonna publish?
It's well. That's the next question, isn't it? I don't know yet, because one of the big reasons for that is because I decided on a whim to approach Joe Decuir about my findings, and I knew that Joe was working on a book detailing his experiences with the 400, 800 machines, and maybe this is something he would want to look at. Sure, maybe, perhaps. Joe wrote me back about 5 minutes later and said, "Hello, Tom. I am very impressed with your research and your findings."
Wow.
Yeah. Understate, And
you're just like, I'm done. Walk away. Mic drop, right?
And he's like, so he said, "So look, I'm in the process of writing a book, and this would be excellent to talk about in the book, et cetera, et cetera." So he and I have been talking back and forth about all of that, but he also put me in contact with another person that you guys have interviewed recently, Liza Loop. And Liza, her eyes popped out of her head and said, "Look, we're building a museum, a virtual museum, online museum about the history of computers in education. Mm-hmm. We would like to feature the work that you've reclaimed. Would you be interested?" And, that's where that's been left at this point. So,
nice. Wow.
Yeah. So, it's been an interesting ride, and this was just something, it was just an interesting spelunking expedition that opened up into this whole other world of craziness that, I had never thought about. And as I keep looking into the historical aspects of how all this came to be, I'm amazed that it got made in the first place, because I'm sensing that there were a lot of forces trying to prevent this from ever actually getting out the door.
Well, you can tell me why you think that, because I've interviewed one person who was a middle manager at Atari, and the interview has not yet been published, but he told me directly he tried to kill this project. He thought it was stupid.
History, based on everything that I've managed to read for all the different projects, Atari had a history for killing projects left and right, mm-hmm. for way too many different reasons. I don't know. It definitely to me just seems from the little details that this thing had a very checkered past. But here's the point I'm trying to make. The guy you mentioned, okay, yeah, I wanted to kill it. Fine. What are you going to replace it with? There was nothing else.
Right.
Nothing else existed.
Right. I could see how this would be a huge win, a perceived win, at least something to try for both Atari and for the Dorsett Educational Company. Here's this little company that's making film strips, and they're like, all of a sudden, they can be launched into the computer realm by the biggest company in the world, or what's about to be. Atari has this new computer and has no content for it, and
Yes.
manages to go to this outside company that has all these educational things, and people are going to maybe use computers for education. They don't know, but let's find out.
Yeah, exactly. And at least from what I've been able to figure out from Dorsett's point of view, this company and the guy behind this company, Lloyd G. Dorsett, he was a bit of a visionary. And you have to come back to, he started his first company in 1946 to basically find something to do. He finally settles into the business of building education machines in 1957. By 1965, he is one of the leading suppliers of what I can only call interactive film strip machines to virtually every big education center in the U.S., as well as military and government contracts all over the place. So he's doing okay. But then he decides, if you actually he has a book called Audiovisual Teaching Machines. It's published in 1970. And if you can get a copy of this book, it's a really good read, because if you look at what he's talking about here, he's mapping out the future of what he called computer-aided instruction. And that computers and computer software along with synchronized audio and video content, we're going to be the next big revolution in education. In 1975, he embarks on a little project which he calls Talk and Teach, to take and convert all that film strip material over to a computer-based format. Now, the details of that computer-based format, I've only been able to piece together bits and pieces of what he had to do. But from what I see, he took an S100-based machine, we'll call it an Altair or an MSI or something, and popped a tape interface onto the side of it, which he had modified to do audio output as well. And the key difference, one of the key differences here, is that the tapes, as they came from Dorsett, used the Kansas City standard tape format. Now, that's 300 bits per second. That's half of the bit rate of the Atari cassettes, and slightly different mark and space tones. And they're projecting onto a screen that is approximately 32 characters long by 16 lines. Okay. Which makes perfect sense. I mean, that's TV typewriter territory. That's Don Lancaster's TV typewriter circuit, so that makes perfect sense that they would take that and repurpose that. Maybe they added some additional circuitry for color. That, too, would pan out because of the limited color palette that's actually available to the Atari Educational System, and there's a grand total of 6 colors. 4 of them are red. Go figure that one out.
That seems strange. There's so many colors on the Atari. Like, they couldn't...
It's literally, it's dark red, magenta, red, brown, and then you've got blue and green. You can do that.
I wanted more of a bright pink. I wanted to...
Yeah, it's just, that's all you got. That's it. You can see the weird vestiges of all of this, and if you actually look at the all about Atari, the all about cassettes memo that I keep referring to, they keep talking about the fact that they had to basically take Dorsett's demodulator and jerry-rig it onto an Atari 800 that they had in the lab, and they wrote a special version of the Education Master Cartridge that would read the data coming in off of the demodulator and then spit it immediately right back out to tape, right back out in the Atari format as it was doing it on the fly. So it's some of the things that they had to do to get this working. There's some definite engineer complaining inside that memo because the tapes were in kind of a weird, shoddy format. But anyway, the fact that they were able to get it working was quite a miracle, and it actually proves beyond a shadow of a doubt that if you want to make your own tape formats on the Atari, go right ahead. You can bit bang the pokey to do whatever the hell you want, as long as you set the clock. As long as you set the clock right in the beginning, and as long as you keep the clock set, you use some sort of timing to readjust the clock to account for tape jitter. Then you're fine. And that really is the funny thing. The irony of it all is, the tape system on the Atari is very asymmetric. The pokey does all of the recording aspects, and the 410 tape recorder itself does all the decoding. On the 410, you basically have a set of bandpass filters that go into a set of comparators that output a square wave for pokey to clock to. What that basically means is, if you wanted to output a tape in Kansas City standard format for another computer from the Atari, you could. The 410 just couldn't read it. It's FSK, so you can program the pokey two-tone mode to output whatever two tones you want.
Huh. Wow. Dorsett also released these tapes for Tandy, definitely
Yes.
for Tandy, and maybe for other computers like Commodore.
Yes, they did. The Apple II, and in each of those cases,
Mhm.
what they did. This is the funny part. For each of those cases, what they did is they wound up bundling their own card or their own hardware with it to basically read these Atari format tapes. So they wouldn't have to remake them again.
Oh, yeah. I mean, okay. Just, I was thinking, as I have this box here of tapes. It's a huge box. It must weigh 60 pounds, filled with tapes. And they had, 45 at least classes, and each class had 8 tapes in it. It's a lot of tape, and it had to be just a lot of material, of inventory for them to manage. I can totally see them going, okay, we can't double this just for another format for Tandy. We can't triple it again when we go to Commodore. They wanted to have one system that would work with every machine.
It carried Dorsett all the way through to at least 1985, 1986. But after that point, it's very interesting. They went off into other ventures. They did at least one interactive video disc venture with a company, and they were starting to do interactive CD-ROM type stuff when they got folded into yet another venture and subsequently disappeared. And this is it's weird because I'm still trying to track down to a certain extent what happened to Dorsett after about 1989, 1990, because after that point,
I was wondering that too, because this was a publicly traded company.
Yes, they were gone.
This wasn't just like a little mom and pop operation and Lloyd dies and they go away. They had stock. What happened to this company?
I don't know. And if we ever find any of these people to talk to them, I would love to spend 30 minutes to an hour just talking to them to get the historical context of the company, because this company is virtually unknown to anybody outside of the education industry. And it's not to say that they weren't without their faults either. It's kind of funny. We talk about, especially in education today, we talk about standardized testing, and we talk about the metrics of that standardized testing affecting everything from school placements to funding, etc. Well, these ideas aren't necessarily new. They were tried in a much more aggressive form in the late 1960s, early 1970s. There was actually an experiment to take a number of school districts in the South, particularly, I believe, in Alabama and a few other places, and have companies like Dorsett run their education system. So they basically implemented their stuff across the board and tried to do testing metrics with it. Well, what they found was that the metrics drove everything so much that the teachers and the people administering these tests were actually feeding the students the answers to these tests almost verbatim in order to keep their scores up.
So it's what we now call teaching to the test.
Teaching, exactly. That is precisely it. And yeah, it's not a new concept. It was done before, and that almost sunk Dorsett for good. That little scandal, because it reflected badly on them, and who knows what was being poked and prodded in that direction to make that happen. So, wow. Yeah, little things that you find out when you start digging through. You find little news articles on this stuff, long since buried.
Yeah, interesting. I want to talk briefly about our project of digitizing the tapes. So basically, you and I are working together. My job is to take these tapes. I'm just shoving them into the machine. I'm digitizing them. And you are then cleaning them up, doing the magic. And I want you to briefly talk about, so people understand what you're doing and why it's important.
Absolutely. Well, the tapes that you're sending me are essentially, you're recording them from an analog source directly into digital. They are often very quiet recordings. Understandably so. That's fine. You don't want them to be. You don't want the recording signals to be too far up, or they'll clip, they'll overdrive, and we won't get a clean signal. So what I'm having to do first and foremost is to take the digitized recordings that you brought in, to use a process called normalization, which basically finds the loudest portion of the recording, and then brings up the rest of the recording to that loudest point, and then brings it up again to match the total signal floor. So you're bringing everything up from approximately -5 or -6.0 dB, where you're bringing them to me now, and we're bringing them all the way up to 1 or 0 dB, making them nice and clean and loud. The other thing that I'm trying to do is I'm trying to cut out any extraneous parts of the recording that do not contribute anything to the content whatsoever. And this is especially important because, like in the context of Altera, the emulator, it is literally looking at every single piece of the waveforms, trying to decode, ones and zeros, trying to find the data. And, well, even in the silent parts of the tape, there's noise. And that noise, even at the quietest levels, you take and you amplify it to try and get a signal out of it, you'll get some data out of it. So if you don't cut those pieces out, you're going to see garbage appear at the start of a lesson or at the end of a lesson, in between lessons, that sort of thing. So let
me interrupt you there for a minute. Because you said before there's error correction, and yet the slightest little pop and click adds junk onto the screen.
Yes.
Was their error correction just terrible?
Well, no. Okay, first of all, there's the error correction that's there is not much more than just the basic pokey serial framing, making sure that the start bit's in the right place, making sure that the stop bit's in the right place, making sure that there are 8 data bits in between the start and the stop bit. And other than that, there is no error correction. So the only other special magic bit in all of this is the fact that all zeros turns into what's called a timing bit, so that you have the software looks for a set of 2 null bytes, one right after the other, 0, 0, 0, 0, and uses the time that it waits between finding both of those bits to figure out, okay, what speed am I at? You're basically generating a fraction which adjusts the baud rate of the tape recorder, that sort of thing. But like I said, all the extraneous data has to be pulled out. The volume has to be normalized. And I'm trying to get rid of some of the excess noise. One of the aspects of analog tape recording, especially in the early 70s and mid to late 70s, was that channels bleed over, especially in this, 1/8-inch, these teeny tiny 1/8-inch tapes that we're using in cassettes. So you would hear the data track bleed over into the voice. I'm trying to get rid of that as much as I can, as well as the tape hiss. And there are even situations where you have pops and clicks in the tape. Well, in some of those cases, I literally have to go in with a pencil tool and remove those pops and clicks and reconstruct the sine waves and some of the audio to get rid of those pops and clicks. Sometimes that can take, if there aren't any pops or clicks or anything I have to restore, I can get a tape done in about 5 minutes. But I've actually spent an hour or so repairing pops and clicks on one of the tapes before, so it varies. It's it's a bit like going in, digging up dinosaur bones with a brush and going through and picking off bits and pieces of a chisel, making sure not to pull too much off, that sort of thing. So yeah, it's interesting, and I wouldn't be doing this if I didn't love what I was doing and I didn't think that what we were doing was very important.
Yes, I think it is too. And I like that we're releasing your cleaned up versions, but also we're releasing the raw, ugly versions if somebody else a better way to do it in the future or whatever.
Absolutely. One other small detail, each of the files that I'm cleaning up to has all of the information about each individual side of the tape that we're encoding in the metadata. So we have the title of the lesson, the album that it's from, etc., and all the information that you would need to catalog the file is part of the metadata. And we're also, of course, at your request, we're also putting it as a text file in the archive that I'm shipping up to you as well. So I'm loving this because I'm loving what I find here, and this is an important piece of history, especially when I hear left and right about how Apple and education were neck and neck together from day one. And, you hear about all these people saying, well, if it wasn't for MECC, we wouldn't have computer-based education in schools, and just on and on and on. Right. But virtually nobody has ever talked about this, what I consider a far more aggressive and forward-looking idea of multimedia presentation on a tape. And, good God, nobody else was doing this. And nobody else could do anything comparable for another 10 years. But it was just this weird serendipitous luck of the fact that you had a cassette tape that had voice and data tracks, and you could use them both at the same time. Wow.
If you enjoyed these interviews and would like to contribute something, I encourage you instead to donate to one of our favorite organizations, the Internet Archive, at archive.org. The Internet Archive is a nonprofit digital library with the stated mission of universal access to all knowledge. They've done incredible things to preserve computer history, including hosting thousands of programs in an in-browser Atari emulator, creating the Wayback Machine, and offering full-page scans of countless Atari computer books and magazines. Make your tax-deductible contribution at archive.org/donate.